In this problem, we need to find I sub 1, I sub 2, and I sub 3 using mesh analysis. In order to perform mesh analysis, we need to check the circuit and see if we don't have any current sources. We can see that we have two current sources that needs to be removed. First, we need to remove the current sources. We have 1 amp current source between mesh 1 and 2. Next, we need to remove the dependent current source at mesh number 3. And once we have removed the sources, then we check if we can write mesh equations, and we can see that we can write mesh equations between mesh 1 and 2, and that will be our super mesh. So we write Kirchhoff's voltage law at super mesh 1 and 2, and we will start by writing the voltage, that is 20 volts, plus the current across this 2 ohm resistor. The current that flows there is I sub 1, so it's 2 plus 2 is 4 I sub 1. Then this 1 ohm resistor receives contributions from I sub 1 and I sub 3, so it's 1 I sub 1 minus I sub 3. The next two resistors only receive current from I sub 2, so it's going to be 2 I sub 2. And then the next resistor, the 2 ohm resistor, receives contributions from I sub 2 and I sub 3. The direction of the current and the direction we're going along on the mesh then tell us that it's going to be I sub 2 minus I sub 3, and that is going to be equal to 0. So reducing our equation, this is going to be equal to 5 I sub 1 plus 4 I sub 2 minus 3 I sub 3 equal to minus 20, and this is going to be the first equation. We see that we have three unknowns, I sub 1, I sub 2, and I sub 3, so we need more equations. And now we're going to write equations from the removed sources. The first removed source was a 1 amp source between mesh 1 and 2. So we write the 1 amp current I sub 1 in opposite direction, current I sub 2 in the same direction. So we write I sub 2 minus I sub 1 equal to 1. And that will be our equation number 2. The next dependent source, the current I sub 3 is in opposite direction of the dependent source, so I sub 3 is going to be minus 2 I sub x. I sub x is a dependent variable, so we need to write an equation and find that variable on the circuit. We can see that I sub x then is equal to I sub 2, and we write that equation. I sub x equal to I sub 2. I sub 3 then is equal to minus 2 I sub 2, and we can rewrite the equation 2 I sub 2 plus I sub 3 equals 0, and that will be our equation number 3. Now, since we have all the equations, we can rewrite equation number 1 as 5 I sub 1 plus 4 I sub 2 minus 3 I sub 3 equals 0. Equation number 2 was minus 1 I sub 1 plus 1 I sub 2 plus 0 I sub 3 equal to 1, and the equation 3 was 0 I sub 1 plus 2 I sub 2 plus 1 I sub 3 equals 0. We can write this in matrix form, and we can start with the matrix of coefficients: 5, 4, minus 3, minus 1, 1, and 0, 0, 2, and 1, followed by the vector of currents, I sub 1, I sub 2, and I sub 3, and then minus 20, 1, and 0 as the result. In this case, the general determinant will give us 15. The determinant 1 will give us a value of minus 30. Determinant 2 will give us a value of minus 15. And determinant 3 will give us a value of 30. Knowing the determinants, we can find the values of the current. Determinant 1 divided by general determinant minus 30 divided by 15 is going to be equal to minus 2 amps. Current I sub 2 is going to be determinant 2 divided by general determinant is going to be minus 15 divided by 15 is equal to minus 1. And current I sub 3 is going to be delta 3 divided by general determinant 30 divided by 15, and is going to be positive 2 amps. And those are the currents for this problem.